Hello student, in this video I would like to discuss about organic chemistry according to IGCSE. So in organic chemistry mostly we are going to discuss compounds that are composed of carbon as one of its primary connector. Carbon is a very flexible atom because it has 4 electron valence, meaning that there are 4 electrons on the outer shell. So if it has 4 electrons on the outer shell, means that it can create like 4 different bonds. For example, here methane, you can see that one carbon is bound to 4 other hydrogen atoms. It is possible because one of each carbon's electron can form a single bond with other hydrogen that requires 1 electron each. Carbon is also very flexible because it can also form carbon-carbon double bond. For example, like this. Here you can see that this is ethene, and here the carbon on the left actually shares 2 electrons with carbon on the right. Why this can happen? Because carbon would like to fill all the outer electron to be 8. So then carbon shares 2 electrons with the carbon on the right and also take 2 other electrons from hydrogen. In this case, each carbon would have 8 electrons. So the main bonds that we see in organic chemistry mostly are covalent bonds, now that we are studying this. So in organic chemistry, actually we have a term to call family or members of different groups. So we call it like homologous series. Homologous series means that they are within the same family. So they have like very similar chemical characteristics. So there are 4 main ones: alkane, alkene, alcohol, and carboxylic acid. While alkane and alkene are mostly hydrocarbons. Why are they called hydrocarbons? Because they contain mostly carbon and hydrogen. So only carbon and hydrogen. While alcohol and carboxylic acid, they are called carbon compound because they contain carbon, hydrogen, and oxygen. Okay. So carbon compound actually can be differentiated into hydrocarbon, which only consists of carbon and hydrogen, and also other carbon compound. In hydrocarbon, we have what is called by saturated hydrocarbon and unsaturated hydrocarbon. So saturated means that you only have single carbon-carbon bond everywhere, while in unsaturated hydrocarbon, we have double bond or more. Double bond carbon. So we symbolize it like this, or even triple bond. For alcohol and carboxylic acid, in this chapter, they are considered to be saturated because they don't contain any carbon-carbon double bond. So it's called saturated. Saturated means that it can no longer be added with hydrogen. So it means like it's full of the hands. So one carbon must have 4 hands. Why 4 hands? Because one carbon only has 4 valence electron. Because if it has like only single bond, so all the hands are full. So it does not have any possibility for the hands to be broken down and added with something else. That's why it's called saturated. It's enough. Okay, so now let's get to the naming. With the first group, it's called alkane with A-N-E. So actually all of these 4 groups share like a very similar rule that you kind of have to remember these 8 numbering terms. So from 1 to 8. So met, et, prop, but, pen, hex, hept, oct. So these terms are used to symbolize the number of carbon on the main branch. So 1 to 8. I think this should be enough. Okay, now let's start with alkane first. Alkane. For every alkane, we have a general formula. The general formula for alkane is CnH2n plus 2. Meaning that if you want to make an alkane, for example, an alkane that has 3 carbons, then we can actually predict how many hydrogen it is. So because we choose 3 as the n, so the number of hydrogen would be 2 multiplied by 3 plus 2. So would be C3H8. So this will be the molecular formula. Sometimes this can be a good shortcut for us to determine the molecular formula compared to drawing the displayed formula. So here, we have what is called by the molecular formula. Sometimes people would also draw it like this. And one carbon has 4 arms, so all the remaining arms would be filled by hydrogen like this. So there are 3 carbon, and there are 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So this is called the displayed formula. Displayed formula. On some past papers also, they can appear like this. So 1, 2, and 3. So every point here means that it is 1 carbon. So this is called the skeletal formula. People would also sometimes draw it like this: CH3, CH2, and CH3. So it's called structural formula. All of these are okay actually, but I would like to refer to displayed formula most of the time because we can see exactly the number of hydrogen. It's easy for us to follow. And sometimes the question would also give you instruction in molecular formula. So if you see, for example, C3H8, then you can actually identify whether it's alkane, alkene, or alcohol. How? Depend on the formula. If it contains only carbon and hydrogen, you could suspect that it could be alkane or alkene. But then you have to check the formula, the number. If it is fulfilling this formula, so 2 times of the number of carbon plus 2, so the hydrogen is more than double the number of carbon, it should be alkane. So all of the drawings that you draw should be carbon-carbon single bond and filled with hydrogen atoms. So here we have 3 carbon atoms. So here, if we see from the naming, that 3 is actually prop here. So we would use prop as the prefix of our carbon name. So here, because it's alkane, so the name for this thing is propane. Propane, because it contains 3 carbon, and ane, because it's alkane, propane. For example, if you have, let's say, 4 carbons like this, so fill all the arms with hydrogen, the displayed formula, or you would like to write it as C4H10, we can also do it like this. It's called butane. Why is it called butane? Because 4 is actually but. And we know that this is alkane because it fulfills the formula. So we call it butane. So here we have butane. At times, there would be some branch in your main alkane. How would we name such compound? For example, just for simplicity's sake, I will draw like this. So if it contains a branch, so there are some steps that are required for you to do. First, you must determine the longest chain. This we call as the main branch or main chain. How can we find? So we have to find from end to end the longest carbon to carbon. From end to end. It can bend, but it cannot jump zigzag like this. It cannot do. So there are some options. Here you see that this is end to end. You also have this possibility. This is also end to end. You also have this possibility, end to end. So here, if we choose this option, you have 4 carbons as your main branch. If you do this, you have 3 carbons only. So we must select the longest one. So it must be like this. There are 4 carbons here. So what do we call alkane with 4 carbons? It's butane. But because it contains a branch here, so we have to name it differently. We have to identify the branch. To identify the branch, we have to give numbers. To specify the location of the branch, give numbers closest to the branch. So we start from end to end, and the number should start from the carbon end that is closest to the branch. So we would start 1, 2, 3, and 4. And now, let's give name to the branch. Because this branch contains only one carbon, the name of a branch is determined as alkyl. Alkyl. Because it contains only one carbon, and the prefix for one carbon is called met, so the name is officially methyl. So this is called methyl. Hence, if we combine everything, we have a butane that contains a methyl branch on the second carbon. So, in summary, the name would be 2-methyl butane. So you can name it as such. The number of the branch, the name of the branch, and the number of the main chain. So this is for alkene, mostly like this. Even though here you see that the main branch is butane, but the number of carbons here are still 5 carbons. Why? Because methyl is giving 1 carbon, and butane is also giving 4 carbon. So in total, there are 5 carbon. So if you would like to write the molecular formula for 2-methyl butane, it will be C5 and then H12. So if you don't believe me, you can try to check this and draw all of the remaining hands of carbon, fill it with hydrogen, and then it should show 12 hydrogens. This is the naming for alkane. Now let's move on to the second group, second homologous series, which is alkene. So for alkene, it contains carbon-carbon double bond. This is the identity. And the identity, we call it as functional group. Functional group is a part of the bond, a part of a compound that gives identity or characteristics of the homologous series, so of the family. So in this case, alkene, the functional group is carbon-carbon double bond. And the general formula is actually CnH2n. So if you see if the number of hydrogen is exactly 2 times or twice the number of carbon, you can be assured that it is alkene. For example, 4 carbon, meaning that the hydrogen should be 8. So it should contain double bond somewhere. So an example of double bond would be, for example, I draw only 3. Be careful that this carbon, it already has 2 hands bind to the carbon on the in the middle, so it has 2 more hydrogen only. Here in the middle, it already has 3 hands, so 1 more hydrogen only. So it should be like this. So if you count 1, 2, 3, 4, 5, 6, it will be C3H6. This is an example of alkene. How would we name it? So same rule, there are 3 carbons. The prefix for 3 carbons is prop. And this is alkene, so it's called propene. It's called propene. Now let's move on to a rather complex alkene, for example, like butane. We have butane like this. It's called butane because it has 4 carbons. However, we can also draw butane like this. This is also butane. Then what's the difference between the first drawing and the second drawing? Actually, the location of the double bond. How can we distinguish the name? So, if you can do this main rule. So, similar like alkene, determine the main branch, the main chain should be the longest chain, but it should include the double bond. So the double bond, carbon-carbon double bond, should be included in the longest chain. Then you can give number closest to carbon-carbon double bond. So for example, here, the first drawing, we have this and this. The first drawing, let's give a number from carbon that is closest to double bond. I think this should be 1, 2, 3, and 4. While for the second one, I think it should also be 1, 2, 3, and 4. So now, because the butene on the first picture, first drawing, is actually starting the double bond from carbon number 1, we can call it specifically but1-ene. So instead of just butene, we call it but1-ene. And for the second drawing, because the carbon-carbon double bond starts from carbon number 2, we can call it but2-ene. So here we have but1-ene and but2-ene. We cannot have but3-ene. Why? Now let's try to draw but3-ene. Something like this. Okay, so you might suspect that this is but3-ene because you want it 1, 2, 3, 4 like this. But it's actually not allowed. Why? Because this does not fulfill the second rule. The second rule. Give number closest to carbon-carbon double bond. And the closest to carbon-carbon double bond is actually here. So 1, 2, 3, 4. So we can start the numbering from left to right or right to left. In this case, it is still but2-ene. Sorry, but1-ene. So here is how you can draw alkene. If your alkene contains a branch, you can also give the numbering closest to carbon-carbon double bond. So let's say that you have something like this. This is double bond, this is a branch. So now let's choose the longest main chain, which is this. And then let's do the numbering. It can be from left to right or right to left. However, we choose from left to right because in this case, the carbon-carbon double bond would get number 2, which is much less. At number 3, we have a branch. Because it contains one carbon, we call this methyl. It contains 5 carbon as the main chain, so we can call this pentene. But because the double bond exists at number 2, we can call this pen2-ene. The pen2-ene contains a methyl branch at number 3, so the full name would be 3-methyl pen2-ene. This would be it. So this is the rule for naming alkene. Now I would like to move on and give you the rule for naming alcohol. So the general term for alcohol, general formula is actually CnH2n plus 2O. So it contains oxygen. And the functional group is actually OH. So this is the functional group. So the OH is actually the one that gives the identity of alcohol. Because of this branch, it makes it alcohol. So the naming for alcohol is actually ending with anol. And later we will see. For example, we have a simple alcohol. So 2 carbon like this, OH, and then the remaining we fill with hydrogen. This is a very common thing that we see. Often we can also draw it like this. If you want to draw the molecular formula, you want to write the molecular formula, it can be C2H5OH, or it can be C2H6O that fulfill this rule. So these two is basically correct. You can write these ways. What would be the name for this? Because it's an alcohol, it contains 2 carbon, and the prefix for 2 carbons is at. So the name for this is actually ethanol. So ol is the suffix for alcohol. So it contains 3 carbon, it's propanol, it contains like 4 carbons, it's butanol, pentanol, hexanol, and so on. So now what if the location of the OH functional group is not at number 1? Then we can have some possibility as well. For example, we have this thing. This thing, because it contains 3 carbon and it contains OH, so we can be sure that it's an alcohol. We can be sure. Contains 3 carbon, so it's prop. Then it's propanol. Propanol is the name. But we can also draw with 3 carbon and the OH is in the middle. So how can we name this? What's the difference between the first drawing and the second drawing? Is the location of the OH group. In this case, we need to determine the number. So we need to number the carbon atoms closest to the OH functional group. So in the first drawing, this would be the closest to functional group 1, 2, 3, so right to left. And on the second drawing, 1, 2, 3, whichever, it's actually the same. Whether you start from left to right or right to left, in this case it's the same. So left to right or right to left is the same. So the name for the first alcohol is actually propan-1-ol, while the name for the second drawing is propan-2-ol. So these are the names for these organic compounds. So now, let's give a name for the final homologous series, which is carboxylic acid. So the functional group for carboxylic acid is actually rather complex. So it's C, double bond O, and OH. So if it contains something like this, it would be considered to be carboxylic acid. The general formula for carboxylic acid is actually CnH2nO2. So out of these 4, it's actually quite easy to identify. If your molecular formula contains 2 oxygen, it's carboxylic acid. Contains 1 oxygen, should be alcohol. Then you can check the number of hydrogen to determine whether it's alkene or alkane. So now let's draw a carboxylic acid that has 2 carbon. So like this, double bond O, OH, and then let's fulfill the remaining arm of the left carbon with hydrogen. Now we have a carboxylic acid. Why do we know it's carboxylic acid? Because it has this functional group. And then it has 2 carbon. So in this case, we know that the prefix should be at. The general name for carboxylic acid is alkanoic acid. So in this case, it becomes ethanoic acid. If it contains 3 carbon, like this for example, double bond O, OH, it's called propanoic acid. If it contains 4 carbon, 1, 2, 3, 4, double bond O, OH, it's called butanoic acid. So it always blah 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 oic acid. So here are some general naming rules for the 4 homologous series that we learned. Now to enhance our understanding, I would like to discuss the reactions that involves these 4 homologous series. Okay, can be quite lengthy reactions. So later I would like to summarize, maybe I would like to make a summary here. So here we have alkene, for example like this. So alkene can actually be substituted under UV light. It's called a substitution reaction. So substitution. So in substitution reaction, usually we can use halogen, for example like chlorine or bromine gas, Cl2 or Br2. How is the mechanism? So now let's discuss in greater detail. So for example, we have ethane, and then we add with chlorine gas under UV light. The UV light will be able to actually cut the Cl to form Cl radical. But this we will not go into greater details. But long story short, the UV light will be able to break the Cl-Cl bond. Carbon-carbon single bond actually quite stable, so it's quite difficult for Cl to infiltrate within this compound. So what it can do, because now the Cl has been broken by the UV light, now it has the capability to snatch one hydrogen atom. So in this case, it will snatch the poorest carbon, so the carbon that has least number of hydrogen. least number of hydrogen. In this case, the left carbon and the right carbon is the same, so it's not one of these, and it will form hydrochloric acid, while the empty space from the hydrogen that is snatched is replaced by the other Cl. So the Cl will go here, making the final product to be, so this thing will be the same. This will almost be the same, except it has one Cl here, and then it will also produce a byproduct of hydrochloric acid. So here, this ethane contains Cl as the branch, and here we call it chloro branch. So that is why here we call it chloroethane. Cl as a branch, we call it chloro. So technically, substitution happens when one atom is actually replaced by another atom, and it produces also byproduct. See, it does not produce only one product, but it produces two products. So it's called substitution. So alkane can be substituted to form haloalkane. So alkane that contains halogen. Okay, for example, like this. So this is the first reaction that can be done. Alkane substituted to form haloalkane. Chloroethane in this case. Alkane can also be transformed to form alkene. In what way? By the process of elimination. So if we are able to remove hydrogen from this atom, from this compound, from alkane, then we will get double bond. So let's say here, we have an ethane. Let's use the simplest example. And then we try to do elimination, usually using a catalyst. The catalyst would be metals. So this process would eliminate hydrogen. It takes two hydrogen from two neighboring carbons. So two neighboring carbons. So let's say that it takes this carbon and this hydrogen and this hydrogen. So they will both be released, and they will be released as hydrogen. So what it will do is that the carbon will have one empty arm each, and this empty arm will actually be forming a new bond. So that is why we will have a double bond here, and from ethane we will have ethene. What if the alkane has more than two chains? Let's say that it has three. Something like this. If you do elimination on this, then you would remove actually hydrogen from two neighboring carbons, two porous carbon. So let's say that this is the porous carbon. Why? Because it only has two hydrogens. So now this one of this carbon must be released, and then one of which from the neighboring carbon. Let's say that this one. So they will be released as hydrogen gas, and then the released one will form carbon, carbon, carbon. This one hydrogen still exists. This one empty hand, and the left one will be intact. So this will form a double bond. So it will form propene. From propane into propene. So from C3H8 becoming hydrogen gas and C3H6. So you can see that here, by releasing hydrogen gas, we will have propene. We will have a double bond. This is called elimination because we are removing some atoms from a compound. From single bond only, from saturated hydrocarbon can form unsaturated hydrocarbon. So for example, can form this. It can also go back here. How? Via addition. Addition of hydrogen. So in case if you have carbon-carbon double bond, it will be the most reactive part of that compound. So for example, like we have this. So we have propene. The way that we can turn this back into propane is by adding hydrogen gas. If you add anything to double bond, the double bond will be the first to react. It's very reactive. So here, for sure that the double bond will be destroyed. Hence, the carbon will open one arm each. Since there are two hydrogen atoms, then they would fill this. Meaning that this will be the final product. So it's quite easy. If you see alkene or carbon-carbon double bond, you would just destroy that double bond and fill everything so that the double bond will be filled completely. This is called addition. Why it's called addition? Because all of the things that are added goes into the compound. Nothing is wasted and nothing is substituted. From alkene, we can also have addition of, let's change the color, addition of, let's say, Cl2 or Br2. So we can call it chlorination or bromination, depends. So here, for example, we have a double bond and then we add Cl2. So both Cl will actually go into the double bond, something like this. Okay, so specifically I will do it here. So let's say that you have propene, something like this, and then you add Cl2 or let's say Br2. Because it contains a double bond here, it's quite reactive. So Br2 does not need to rely on UV light in order to break the Br-Br bond. It does not need the UV light. It's already reactive enough. Br2 can already infiltrate this alkene. Okay? So Br2 will be broken. It will break the double bond, open the arms of carbon, and the Br will both enter the leftovers of the empty hands that is created from the disembowelment of this double bond. So what would we call this thing? Because it's technically a propane, but this propane has two Br branches. So we have to give number. The number start closest to the branch. So 1, 2, 3. And then because on carbon number 1 it contains bromo, so we call this bromo. This is also bromo. So the name will be 1,2 dibromo propane. Or sometimes people just call it dibromopropane, dibromoethane. That's also okay. But to be specific, 1,2 because it contains two bromo branches at two different positions. And what's the meaning of di here? Meaning that you have two branches of bromo. So two branches of bromo at position number 1 and 2. Something like this. They rarely specify this detail in such detail. So just so that you know. Anyway, Br is normally kind of brown. But because you mix it with something that can actually disassemble Br2, the final product will be kind of colorless. Because there are no longer any molecule that gives out the brown color. So that is why we often say that alkene actually decolorizes Br solution. So anything that contains double bond can decolorizes Br2 solution or Cl2 solution. They have distinct color. Okay? So this is called addition because everything goes in. So for alkane, we have one more addition, which is addition of water. So addition of water will actually lead to this. So the water will be disassembled to H plus and OH minus. Later the detail will be given to you in upper grades. And then the same, the double bond will be destroyed. One will get the hydrogen, one will get the OH group, making this an ethanol. So addition of alkene would produce alcohol. So now this is alcohol already. So here we have alkene and alkane. And finally, alcohol can be oxidized. So to be oxidized means to lose electron or to gain oxygen atom. So it's kind of easy. So for oxidation, you technically just change this OHN into double bond O and OH. So technically, if it is ethanol, then it just becomes ethanoic acid. So what you need to change technically is just this part, the functional group part. They would change. So these are actually some basic reactions of alkane, alkene, alcohol, and carboxylic acid. For all carbon compounds, you can actually combust them. So combustion. Recommendation for combustion reaction is that you would use molecular formula. For example, combustion of propane. Then the molecular formula for propane, because prop is 3, so C3, and alkane is actually CnH2n plus 2, then we know C3H8, then combustion is added with oxygen to form carbon dioxide and water. Then what you need to do, you just need to balance this. So 3, and then 4, and then 5 here. So this is balance. So this is called a perfect combustion. Perfect combustion. Or complete combustion. Perfect or complete. While for incomplete combustion, so technically similar, but the product will be carbon monoxide instead of carbon dioxide. So here, yeah, of course, we balance it differently. That's the only difference. So that's why, for example, if you're burning your engine, your fuel inside an old engine, because the old engine is rather inefficient, the combustion would be rather incomplete, so it will produce carbon monoxide instead of carbon dioxide. Yeah, carbon dioxide is indeed toxic, but carbon monoxide is far more toxic to human. Final reaction in this chapter is esterification. So it's a reaction between alcohol and carboxylic acid to form ester and water. So let me give you an example. So alcohol can be something like this. It's ethanol. Carboxylic acid can be something like this. Double bond O, OH. It's propanoic acid. Then the ester formed from this actually will be forming something. So one of the easy way for me to always do this is that for the propanoic acid, I would highlight it differently with pink color. And then for the alcohol part, I will use yellow. Okay. So I would put my carboxylic acid on this side. Yeah, this is the pink part. The pink part. And then I would put my alcohol in reverse. Okay, in reverse. Now, because they are reacting actually, both this OH will fuse together and they will form a longer chain. But when they fuse, they will remove hydrogen from here and OH from here to remove water. So water will be removed. And the remaining bond will be something like this. So it will be C, C, C double bond O, one more oxygen, and this oxygen actually already lose hydrogen, so it has one empty arm, carbon and carbon. So you see that this part here, the 3 carbon, comes from the propanoic acid, and this 2 carbon comes from the ethanol. So this is called ester. A fusion between alcohol and carboxylic acid that forms such compound. The formal name would be alkyl alkanoid. The part where you fuse your alcohol, we call it alkyl. So because it contains 2 carbon, we call it ethyl. Et meaning 2, il meaning branch. Then the part where you actually fuse your carboxylic acid, we call it alkanoid. So in this case, because it contains 3 carbon, it's called propanoid. Prop because it's 3, noid because it's coming from a carboxylic acid. So together, it's called ethyl propanoid. It's a rather important reaction actually, because of fusion between alcohol and carboxylic acid. Mostly they are used as fragrances and other additives in food industries or other industries. Now let's do one more, just for practice. Let's say that you want to fuse butanol and ethanoic acid. Actually, we can say that from alcohol, it will form the alkyl, and from the ethanoic acid, it will form the alkanoid. So even just judging from the name, we know that the name will be butyl ethanoid. So the one with COO double bond will be 2 carbon, and the one with 4 carbon will be everything single bond. So let's draw this. So ethanoic acid, let's draw ethanoic acid first. So 2 carbon, something like this. This is ethanoic acid, contains 2 carbon, it's carboxylic acid. Butanol, let's draw the OH facing this way, and then 4 carbons. It's called butanol. Now let's remove this, 1 hydrogen and the OH, let's remove this to form water. And now let's fuse this thing. Oh, and then there are 4 carbons. So this part here, we call it alkyl, and this part here we call it alkanoid. So here we have butyl because it contains 4 carbons, and ethanoid because it contains 2 carbon here. So actually, if I give you the name butyl ethanoid, you can kinda predict the materials, the ingredients leading to this product. Butyl ethanoid, meaning that the butyl comes from alcohol, comes from butanol. The ethanoid comes from ethanoic acid always. So these are some common reactions and general naming for 4 main homologous series that are learned in organic chemistry part, organic chemistry chapter IGCSE. I hope it helps. I will leave this note in the link down below.